Welcome back. This is an Aleks training video on predicting how reaction rate varies with pressure, concentration, and temperature. So when you have a reaction, the more often that two molecules, reactant molecules, can slam together, the more likely they are to have the energy required to break the bonds that they had and form new bonds. So two things have to come together in a couple different ways. They have to come together oriented the right way. So if you have a very kind of three-dimensional looking molecule, they would have to bang together oriented in the right direction so that something could join onto it or something could break off of it. So just hitting together is not necessarily enough. You're going to have it arranged in a specific 3D spatial way. So not every time that two molecules bump is there going to be a reaction because they might not be lined up the right way. But if they can bump over and over and over again, eventually they may be oriented in such a way that you could break apart bonds and form new bonds. So more frequently that they come together, the more likely you're going to have a reaction. So what can you do to the vessel to make it happen more frequently? Okay. The second thing that you're going to need is you're going to need to have a certain activation energy. That means they're going to have to slam together hard enough to actually make a connection. Just because two things touch doesn't mean that they're going to actually react. They have to come with sufficient energy to break the bonds and form new bonds. So you have to have orientation and energy has to be right. Okay, so knowing that, again, the more they slam together, the more frequently they slam together, the more likely they're going to make something, and the faster the reaction will proceed. Okay, so you're going to have in this particular question different types of questions dealing with making them happen more frequently. So the one that I have, the example I have, is holding the temperature still and differing the volume. Okay. You would also have one where you're changing the pressure and changing the temperature. Let's look at all three of them and then answer our question. So let's say the temperature changes. Okay, so I have temperature 1 and then temperature 2. All right. If temperature 2 is higher, are the molecules bumping into each other more rapidly or slower? Okay, do you see? The temperature has given energy to the molecules. The energy are bopping around, the molecules are bopping around more faster when the temperature is higher. So that should give you some indication that if it's temperature that's all changed, the higher the temperatures, the faster that they're going to go. Okay, the rate of reaction will be faster with the temperature being higher. Lower temperatures would go lower reaction rates. Higher temperatures would have higher reaction rates. Let's imagine pressures. Okay, pressure is putting more and more air into, say, a vessel or different reactant gases into a vessel and crowding them. Do you see? If I crowd gases together, the more likely they are to slam into each other. If you have just a little bit of gas in a huge tank, the gas doesn't even have to bump into each other. It may bump against the walls and every once in a while touch another gas molecule. But if you increase the pressure, higher pressures, what you're doing is you're putting more gases in there to slam together, and they're more likely to happen. So the higher the pressures, usually the faster the reaction rate. Okay. In this case, we've got volume. Now, volume is kind of weird because if I make something bigger, what have I done to the concentration? Okay, if I put something in a big bucket, then I have given it lots of room to spread out, and it's less likely to come together. If I put everything in a smaller, I have the same amount of reactant in a smaller vessel, then it's more likely to happen. It's more likely to slam into each other. So in our case, we're looking for the lowest volume to be the highest slamming together. Okay, so what are our volumes? I've got, well, first of all, let's look at the question. Marble is calcium carbonate, and acid rain is sulfuric acid in the rainwater. So, an engineer is deciding to study the rate of reaction of acid rain destroying marble statues, I think. So, he starts this experiment. He puts some solid calcium carbonate in a vessel and a certain amount of sulfuric acid in it at a certain concentration. Then he fills the rest with water. Okay, so all the temperatures are the same, the volumes are different, the amounts of stuff are the same. Do you see? So as he is in smaller and smaller vessels, he has less and less distilled water because he pours the calcium in, he pours the acid in, and then he tops off the vessel with water. Well, if you have a little tiny vessel, you pour the acid in, you pour the calcium carbonate in, and then there's a little bit of water left over. If it's a huge vessel, you have lots of water. Okay, so you can see the smaller the vessel, the more concentrated the acid is, and the more likely it is the acid will come in contact with the calcium. So I want the smaller one. So the smaller one I see here is a 1 liter vessel. So it's going to be 1, and that'll be the highest. Okay. The biggest vessel is 8, and it'll be number 4, and that's the lowest. Okay, so 1 going to 2, so this is number 2, and this is number 3, and that's number 4. All right, hope that helped you.